So let me just start. This is a system to stabilize, let's say, a small camera or something like that. And the idea is that as you move this thing around, it keeps stable. So where's the camera go? It goes on top of the...
Oh, so that's it there.
It goes in there.
That's just
so
in place of a GoPro.
So it works in both dimensions, okay. All right, so it's really good. So tell us a little bit about it. How does it work? What has it got? Sort of control system in there to work?
There's a motion sensor down here.
Yeah.
This processor is used for data acquisition and filtering, and then the control signals are transmitted from here to here, just using a 2.4 gigahertz transceiver.
Oh, this is so it's a radio waves.
Yeah, so I'm just trying to get that set point across this rotary joint.
Oh, just a set point.
So with this version here, you've got all these wires that.
So this is an earlier. So this is an earlier prototype that worked on LabVIEW, and okay, it's obviously much bigger.
So that's
and we haven't got that running because we haven't got LabVIEW on this machine, unfortunately. But it did work, and so this is a miniaturized version. Now you've got the sensors, a gyro, and an accelerometer.
Yep.
And how are you using that? You've got a Kalman filter, is that right?
Yeah, there's a Kalman filter for the fusing and filtering.
Yeah.
And just a slip ring to get power to that.
So these are AC motors as well?
Yeah, brushless DC.
That's pretty good, isn't it? So you rapid prototype or built? No, you built everything?
No, this is all machined out of aluminium.
Machined. So you did that on a router? Or?
Yeah, just a CNC router.
CNC router, and you did it all yourself?
Yep, and
everything.
The PCBs
so
for
basically everything's yours. Yeah, that's a nice piece of work. Let's just see it again working. So as if you were so it's staying in the upright position. That's actually very good.
Yeah,
so are you thinking of sort of going another stage and taking it to market or something like
No,
this?
I've got a lot more work to do. See, that little oscillation I can't get rid of.
Oh, okay, but that's...
And the speed of this pitch response isn't quite what I'd like.
Yeah,
This is just so you've damped it enough so that it's stable, it doesn't freak out.
Yeah.
But there's still a bit of tuning to do.
Yeah, so what's the sampling rate for this?
This is running at 1 kilohertz. I'm still getting some packet loss when you transmit across here. So these loops should also be running at 1 kilohertz. But you can see it there, that blue LED, every time it goes red, that's the loop timing out if it hasn't received a set point.
Oh, I see.
So that is better than when I started, but I'm still losing a bit.
So why are you sending it by wireless and can't you, is there a reason?
It was just to try and avoid having more wires crossing these rotary joints. I can't make a multiple pass slip ring that has 8 or 9 passes. I can definitely do a 2-pass.
Okay.
If I was going to try this again, I'd look at trying to get a 2-wire interface to work over that power bus.
So let me hold it and try it. I see. So that's me moving it side to side and then going this way. That's a very nice, and this didn't take you too long, the second prototype, did it, compare with the first?
No, but I think it's an easier problem to solve it with brushless because you control position. With that, you're trying to control velocity. You've only got control of the velocity.
I see. So these have got their own little controllers, the AC motors. They come with their own, or did you have to design them as well?
Yeah, I'm using an integrated driver. So
I see.
I did spend about a week trying to match a set of MOSFETs to another more complicated driver, and just gave up in the end. It's much simpler to use an integrated driver.
Well, thank you very much. That's Kieran, who's a final year BE honours project here at AUT, Auckland University of Technology. Thanks, Kieran.
Sure.